Hey guys, this is Mr. Sal. We're going to look at solving 1 and 2-step inequalities. Thanks for watching. Alright, we need to solve these types of problems because this lesson is going to have a lot of this problem solving kind of stuff, which is pretty familiar. But these ones in the lesson are not going to be equations, so this is just kind of good practice for us. So this first one, we got 13 minus that parentheses 2c plus 2 equals 2 times c plus 2 plus 3c. So we're going to have to distribute wherever we need to. Right there I see that's a negative 1, and it's a phantom one that I put right there. But I'm going to distribute that into the parentheses. So negative 1 times 2c would be negative 2c, and negative 1 times positive 2 would be negative 2 right there. Then we'll distribute this 2 into the parentheses also. So that would be 2c, and then 2 times 2 is positive 4 right there. So we've got 13 minus 2c minus 2 equals 2c plus 4 plus 3c. When we did this in, I think it was the second unit, we combined the like terms. So 13, I can combine that with negative 2 because they're like terms. 13 plus negative 2 is positive 11. And then we still got this negative 2c out here in the front. This would equal, I can combine the c's on this side, 2c and 3c. This would be 5c's. And then don't forget the plus 4 right here. So this is the new equation. I'm going to put the c values on the left. So I'm going to subtract 5c from both sides. And when I do that, I end up with negative, actually I'll need the space, negative 7c plus 11, and then this would equal that 4 on the right. Actually I need that with more space. The next step would be to subtract 11 from both sides of the equation. So that leaves me with the negative 7c, these zero out, and 4 minus 11 would be negative 7. The last step would be to divide both sides of this equation by negative 7, which gives us c equals negative 7 divided by negative 7 is 1. So in this equation, c is 1. The next one, 2 times the sum of 4x and 1 minus 2x equals 9x minus 1. So I will distribute the 2 first into the parentheses. So 2 times 4x's would be 8x's. 2 times 1 would be positive 2. And then we got the rest of the equation. So 8x plus 2 minus 2x equals 9x minus 1. Now I'll combine like terms just like we did in that last one. 8x's with negative 2x's would be 6x's positive. Then the plus 2. This equals 9x minus 1. This one I'll put the x's on the right just because I don't want a negative coefficient. So I'm going to subtract 6x from both sides of the equation. And I've got 2 now, positive, equals 9x's minus 6x's. That would be 3x's, yep, minus 1. But let's get rid of that minus 1 by adding 1 to both sides of the equation. So that gives us 3. 2 plus 1 is 3. Equals the 3x's, and yeah, those zeroed out. The final step is to divide both sides of the equation by 3, and we get x equals 1. Well, that's unusual for both the answers to be the same, but it looks like they are in this case. And you could check by replacing the x values with 1 and just seeing to make sure that they are equal. So 2 times 4 times 1 plus 1. That'd be 10 minus 2 times 1 is 8. 9 times 1 is 9 minus 1 is 8. So it checks off. So the objective of this video and of this lesson is that you can solve 1 and 2-step inequalities. Don't forget, you guys, we're going to expect you guys to be able to do this when I get back as well. Take another 15 seconds to copy this down, please. So we need to review inequality stuff, which you guys did in 7th grade, actually, and possibly also in 6th grade. So Inequalities is where it's not just equal or not equal at all. So sometimes in the past, maybe you've seen an equal sign with a line through it, which means that it just would not be equal to. We're not actually going to be dealing with that stuff either, so we're not worried about that. But we are dealing with the other ones, like these. So this first one on the left, that is less than. And then the one on the right is greater than. So we know it's less than because it kind of looks like an L right there. And the greater than one kind of looks like the part of the G. That looks like the greater than part. All right. But those were pretty straightforward. For example, we could have said that 5 is less than 7. And we know that's true because 7 is more than 5. But if I switch this and I said that 5 is less than 5, that is not true because 5 is not less than 5. So that would be false. But there is a way to make this true, and that's the next set of symbols. And that would be less than or equal to, or greater than or equal to. So it's got the less than symbol, but only one of the lines from the equal part, because putting that extra line in there was going to be too much work for the math people, and we're pretty lazy about that. So the next one would still be greater than, but it's got that equal part of it too. So it's not just that it's greater than, but it is also equal to as well. So let's look at an example about that, right? Like 5 and 7, like we did before. Well, 5 is less than 7, that's true. But if I said that 5 is less than or equal to 7, it is still true. Because it only needs to be one or the other, which is why we put or in there with these statements. It doesn't have to be equal to, because it could also be less than 7. So if I said we want to put in another value other than 5, that would work. What would be one of those values? Like 4. Or negative 14. That's less than or equal to 7. Okay. So greater than or equal to has to do on the number line. So negative 14, for example, would be way over here. And then there'd be 0 and 7. Negative 14 is to the left of 7. So anything to the left is considered less than, which means the higher the negative, the lower the value of that number. Number 1 on the worksheet, you are going on a field trip and need to choose where to go. The zoo charges a $100 fee plus $10 per student. The museum charges a $250 fee plus $5 per student. How many students need to go on the trip in order for the museum to be a better deal? So just take a couple minutes and see if you guys can solve this one. So we got to figure out when the museum is the better deal. So there's a couple ways we could look at this, and there's a couple ways you could have looked at it. However, I will write the equation for it. So the first thing is we're comparing the zoo to the museum. And we want to know when the museum is a better deal. And we are looking at costs for these two. So that means the zoo would have to be more expensive than the museum. Not equal to, just more. So I have the zoo as an inequality is greater than the museum. So the zoo, we see they charge $100. But then in addition to the $100, they're going to charge $10 per student. So that would be $10 multiplied by the number of students. We don't know how many students we're going to take. So I'm going to use the variable x. Next up, the museum. It charges $250 to start with. All right. Plus $5 per student. So from the $250, we're going to add also $5 for every student. So we're going to multiply that by the number of students. Now again, this needs to be greater than the zoo, needs to be greater than the museum in cost. So we're solving for x, and either way that we solve it should be good. But for now, we want to solve it so that the coefficients of x are positive because we haven't learned this stuff completely yet. We're going to solve this just the same way that we would a regular equation. So the first thing I'm going to do is I'm going to get rid of that 100. So I'm going to subtract 100 from both sides. That zeroes that out so that I just have 10x now is greater than 250 minus 100 is 150. But then we got to add the $5 for every student. Next up, I want all the x's on one side of the inequality. So I'm going to have to subtract the 5x from both sides. So 10x's minus 5x's would be 5x's still. And that needs to be greater than 150 bucks. Now, just if we were to interpret this, the museum is charging $5 less per student, or the zoo is charging $5 more per student. And the difference between their starting cost is $150. So we got to make up that 150 bucks by dividing both sides by 5. So we'll divide by 5 on this side and divide by 5 on this side. So that means x would have to be greater than 30. Now, this is just the inequality part of it, though, which makes that pretty easy. If we use the guess and test model, we have to create a table, and that can be kind of a pain. So, we got x is greater than 30. Let's just write this out. We'll write the sentence out for this one. So I know x has to be greater than 30, but x represents the number of students. So, you'd have to take more than 30 students for the museum to be cheaper. And that would be the real answer for the sentence right there. Is more than 30 students for the museum to be cheaper. Number 2, one of the most common ways that teenagers start to make money is by selling candies. If you buy a case of candy, it can cost you about $26 for a box of 30 pieces of big candy bars, which means that if you sell each candy bar for $1, you can get a $4 profit, and that would be for the whole box, of course. If you and your friend Jay are both selling candy, we can represent this relationship by using and providing the distributive property. You and Jay sold a lot of candy bars. Let's say you sold 15 boxes in 1 week and he sold X boxes, not the console, but X number of boxes. How many boxes does Jay have to sell if you want to make at least $180 together? So you take a couple minutes, you may have to read through that a few times to solve it, and then we'll go over it. All right, one of the most common ways you can make some monies. Here's what we need to know on this problem, is that you're going to make $4 a box. Now it says that you sold 15 boxes, so we'll go through both methods on this one. So we're going to look at just the freehand method or the guess and test method, and then we will look at the actual formal inequalities method. So the first way is just the informal method, guess and test kind of. Here's what we know is that you and your buddy Jay are both selling these. And when we add the two, however much you make, it needs to equal 180 bucks, or at least 180. So we could say that the amount you make needs to be greater than or equal to 180. We'll use the same setup later as well. All right. Now, here's what we know. You sell 15 boxes, and for each box, you're going to make $4 of profit. So you are going to make $4 of profit for 15 boxes. That means that you are going to sell $60 worth of candy bars. Now, what does that mean for Jay? Well, if you want to make 180 bucks, you're going to have to take the 180, and if you subtract what you made, then we will know how much Jay needs to make from his sales. And that's $120. So Jay needs to make twice as much as you, which is kind of a hint on this. So Jay needs to make $120 worth of money from candy bars. Now here's what we know though, is it's $4 for every box that you guys sell. So, and yeah, it does say how many boxes specifically. So I'm just going to take this and divide it by $4, and this will tell me how many boxes it is that Jay needs to sell. And right here it looks like it's 30 boxes. Now the answer is not 30 boxes though, and we'll discuss that here in a moment. But before we do, remember when you sold 15 boxes, you made $60. Jay needs to make twice as much as you did, so he needs to sell twice the number of boxes. 15 times 2 would be, 15 boxes times 2 would be 30 boxes. But again, this is an inequality, so we'd have to say that Jay needs to sell at least 30 boxes. Jay sells at least 30 boxes. But let's look at this in the inequality also. Alright, so again, we're going to look at the same inequality. It's U plus the amount that Jay makes. This needs to be greater than or equal to 180. We already know that U, we're going to make $4 for 15 boxes. $4 for each box, selling 15 boxes. So 4 times 15. Again, that means U will make $60. Jay, he's going to sell at the same price. He'll get $4 for each box. We just don't know how many boxes Jay needs to sell. So we're going to use X right there. So U plus J, which is 4X, this needs to be greater than or equal to $180. If your goal is to make at least $180. So to solve this, we would subtract 60 from both sides, which is kind of what we did already. So again, this shows that Jay needs to make $120. And he's going to sell $4 for each box. So multiply that by the number of boxes. That needs to be greater than 120. Finally, just divide both sides by 4. And X, that's the number of boxes, needs to be greater than or equal to 30. So again, we get the same answer. Either way that you do it, and that works. So Jay needs to sell at least 30 boxes. Number 3, Billy needs to read 500 minutes this week for his English class. He is going to read 6 days. If he already reads 15 minutes every day, how many additional minutes does he need each day to read at least 500 minutes? All right, yeah, take a minute, take a few minutes and see if you can figure this one out with your neighbor. All right, I'm going to read this again just because you should. Probably read this a few times to solve it. Billy needs to read 500 minutes this week for his English class. He's already going to read 6 days. If he already reads 15 minutes every day, we need to know how many additional minutes he needs to read every day to get to at least 500 minutes. So we want Billy. Billy, he's got his goal, and that's to be more than the required reading, because it says that's what he needs. So he's got his goal and then what he needs. His goal is greater than, but he would be okay if he got just to the 500 minutes, because it says at least 500 minutes. So his goal right now, this is how many he needs. We know he needs 500 minutes. And right now he's going to read 6 days for this week. And from those 6 days, we're going to multiply that by the 15 minutes, but we're going to add an additional some number of minutes, which we don't know yet, so that we can get to that 500 minute mark. That's how many he needs. So his goal is to be greater than or equal to that 500. So now that we've set up this inequality, we can solve it. Just distribute the 6 into the parentheses. 6 times 15 would be 90. And then 6 times x would be 6x. Now again, this needs to be greater than or equal to the 500 minutes, which is how many he needs. So to solve this, we'll subtract 90 from both sides of the equal sign, the inequality rather. So now I've got 6x equals 410. Write that a little better. Then we'll divide both sides by 6, and that will tell us, sorry, I forgot the inequality there. There we go. So the number of minutes x that he needs to read needs to be greater than or equal to 410 divided by 6. So yeah, that's in the calculator, right? 68.3 repeating.
Yeah.
And that's in minutes. So again, since we solved this, we'll just write it as a sentence real quick. So Billy, he needs to read at least that 500 minutes. So Billy needs to read an additional 68.3 minutes every day for the 6 days he will read. Number 4, Kimberly took her 5 nieces and nephews to a hockey game. She wants to buy each niece and nephew and herself a snack. That's not 5 nieces and 5 nephews. It's only 5 total people that are nieces and nephews. Plus herself, that's 6 people, all right? So you got to be careful on that. The tickets cost $4 a piece at the door. How much can she spend on each snack if she has $42 with her? Don't forget to include Kimberly. So again, it's just a total of 6 people, not 11. Not 11, all right? Guys, take a few minutes, discuss that, talk about it with your neighbor, and solve it. All right, Kimberly took her 5 nieces and nephews to a hockey game, but she's going to include herself. So the total people for this problem includes herself. So that's her 5 nieces and nephews plus herself. That's 6 people total. So the 6 people going to the hockey game, and the tickets are $4 a piece at the door. So the ticket, just the dollars from the tickets, is going to be 6 people multiplied by the $4 for each ticket. So that means right there, bam, she's going to spend $24 just on the tickets. All right, if she's going to spend $24 on tickets, and it says that she starts with $42, we're going to subtract the $24 from the $42 and see that she would have left over $18 to spend on snacks. So with $18 to spend on snacks, we know that there's 6 people, including herself. So we're going to divide the $18 amongst all 6 people. So $18 divided by the 6 people. And that will tell us how much she can spend on each person. So with the $42, she can spend $3 for each person. Now this one, if we relate it to an inequality, that's a maximum value, because as soon as she spends more than $3, then she no longer has the money to cover the cost. So it's a maximum of $3 for each person. All right, here's numbers 5 and 6 on the worksheet. Take a minute with your neighbor and see if you can solve these two together. Number 5. Yes, we will solve the inequality, and we will show our work, and then we will, well, I don't know that we'll check, because we're going to treat it like an equation. So we're going to find some value of m that would make that inequality true. And once we figure that out, then we'll see that there's lots of different answers for m. But we're going to solve this exactly like we would an equation, as it turns out. The only difference between these and regular equations, and we'll see this later, is if we ever divide or multiply both sides of the inequality by a negative, then we flip the inequality, or the shall get, whichever way it's facing. All right, so on this one, we treat this just like we would an equation, which means that which means that I would be adding 12 to both sides of this. Now what that does is it zeroes this out with that negative 12 and the positive 12, just like it would with an equation. I'm going to drop the m, and I'm going to drop the inequality, because we did not multiply or divide both sides by a negative. And then 0 plus 12 is 12. Now this is as far as we go. What this means is that if I replaced m, if I said it were 12, into the original inequality, m minus 12 is less than or equal to 0, then m would equal 12, right? So that would give us 0 is less than or equal to 0, which is true. Not because it's less than 0, but because it's equal to 0. Well, we're also saying that up here that m could be anything that is less than 12 as well. So a number that is less than 12, we'll say 5. So I'm going to check this again in the equation and see, does m equal 5 make this true? We'll use a different color. M equals 5. Well, then I got 5 minus 12, which is negative 7, which is still true. So all values that are less than or equal to 12 will make the original inequality true. And this is actually the answer right here that we want. Let's go ahead and solve number 6 then. On this one, we got y plus 7 is greater than or equal to 0. That is correct. We will be subtracting 7 from both sides of the inequality. So again, that zeroes out the 7s. I'll drop the y. We got y is greater than or equal to 0 minus 7 is negative 7. There we go. All right, here's number 7 and 8. 1 minute with your neighbor. Go. All right, number 7 and 8. Hopefully you guys got these ones done as well. Let's go ahead and do number 7. So on this one, it doesn't matter which side the letter's on, by the way. So we want to get rid of that minus 2 to isolate the n. And to do that, yep, we're going to add 2 to both sides of this inequality. Now the math on this you could put in the calculator. Negative 2 plus 2, that's going to zero out. We'll drop the n, and we'll drop this less than symbol. Negative 6 plus 2 is negative 4. Now once again, we could check. If I made n equal to negative 4, then we should get an equal part on this inequality that we started with. But it's not equal to, even though we are checking for equality on this, okay? So negative 6 does equal negative 6 minus 4, negative 4 minus 2 rather, which is negative 6. That's true, but remember that the equal part was not on that inequality symbol. That may not have made sense. We're going to ignore that part. So on this one, we'll check. What is the value of n that is greater than negative 4? We'll say n equals 0, because 0 is greater than negative 4. Then we will check in the original inequality. Negative 6 is less than n minus 2. But we're going to replace n with 0 and make sure that it is true. So that gives us negative 6 is less than 0 minus 2 is negative 2, which is true. Since that is true, we know that this answer is correct. All right, we got to be able to do this with decimals also. So x plus 0.8 is greater than 0. So let's go ahead and show this one then. So I'm going to subtract 0.8 from both sides of this inequality in order to cancel out or zero out that 0.8 there, which will drop the x, and it will drop the inequality, and 0 minus minus 0.8 would be negative 0.8. And that is the answer right there. Now the good news about these types of problems is that we've only had to deal with one step inequalities. So in the last four that we just barely did, all we need to do was either add or subtract, and then we had our answer. Just like it would have been for an equation that required one step. However, we're also going to be covering two-step equations today. So we can also graph inequalities on a number line, and it may help us visualize what numbers make the inequality true. To demonstrate this, let's use that last one. So on number 7, we had -4 is less than n. Now there's an infinite numbers of values of n that would make this work. But if we show this on a number line, then we need to indicate first that -4, where it would be equal, is not a solution. And to do that, we use an open circle. Now it's any value of n that's bigger than -4, which means that it would be all the values to the right on the number line, because those values are bigger than the value that was given to us, which would be -4. So this creates a way for us to graph any inequality that we find. For example, the first thing is if the inequality is just less than or just greater than, then we use an open circle on the number line to indicate that value is not a solution that would make the original statement true. Which is why on this one we have a -4, and at -4 it's an open circle, because the inequality was just less than. Now if it were equal to, we would have closed that circle and filled it in like this, but it wasn't, so we're going to leave it open. The next thing that we need to consider is the inequality, or the shall get, eating the letter? In this one that we've demonstrated from number 7, it is eating the letter, which is why it goes to the right. Now that would indicate that all the values to the right of -4 would give the original inequality, or make it a true statement. If it does not eat the letter, then the line goes to the left. Now some people say, well, it depends on which way the inequality is pointing. That is false. You have to be careful with that, because in the past it's worked, and it only works as long as your letters are on the left side of the inequality, but it will not work if it's on the right side, so be careful on that. We like to look at it in terms of if the inequality is eating the letter. So we're going to demonstrate this on the next several examples and graph these. All right, here's numbers 9 and 10. See if you can solve these and graph them with your neighbor. And it'll be based on the rules that we just went over. All right, hopefully that was enough time for numbers 9 and 10. We're going to solve these two inequalities and graph them on the number line. All right, number 9. Again, one step. All I'm going to do is subtract 7 from both sides of this inequality, and then it will give me the answer, because these 7 zero out. So I have m is greater than or equal to -1 minus 7, which is -8. Now on the number line we should include 3 numbers so that we can tell which way it's going. And at -8, that's where they would be equal to, so that's where the circle will go. To the left of -8 would be -9, and to the right would be -7. Because the more negative it is, the farther to the left it goes on the number line. Next up, I can see that this one includes an equal part in the inequality. So at -8, I have a circle that is closed. So I'm just going to shade that in. The next thing is I see that this inequality is eating the m, which means that this line will go to the right. So all I'm going to do on this one, subtract 6 from both sides of the inequality. So -14 minus 6, just put that in the calculator, give you -20. And this is still greater than t, and the 6 is zeroed out. So at negative 20, that's where it would be equal to t. So we're going to put that on the graph. To the left would be negative 21. To the right would be negative 19. This one is not equal to, which means negative 20 is not actually a solution, but it is where it would be equal. So we have an open circle at negative 20. This one is not eating the t, so it would go to the left of that circle. So again, this means anything or any number to the left of negative 20 would give us a true statement in the original inequality. Negative 14 is greater than t plus 6. Here's numbers 11 and 12. Take 1 minute with your neighbor. See if you can solve both of these and graph them. All right, we're going to solve these two. Hopefully that was enough time for you guys. Let's go ahead and start with number 11. So n minus 11 is greater than or equal to negative 5. I'm going to add 11 to both sides. So that's going to zero out the 11s. We're going to drop the m. And this is greater than or equal to negative 5 plus 11, which is 6. So on the number line, we got 6. To the right would be 7, and to the left would be 5. 6, since it is equal to m, or it can be equal to m, that would be a true statement. So that would be a closed circle. This one is eating the m, so the line goes to the right. So all the values to the right of 6 on the number line would make the original inequality true. Number 12. Negative 5 is less than t minus 8. To solve this one, I'm going to add 8 to both sides of this inequality. So that's going to zero out those 8s. Negative 5 plus 8 is positive 3. And this now is less than the t, which we're going to drop. So 3 is less than t. So on the number line, we got a 3 that should be in the middle, a 4 on the right, and 2 on the left. And at 3, this one's going to be an open circle because it is not equal to t, it's just less than t. And this one is eating the t, so this line would go to the right. All right, here's these two for you guys. Here are numbers 13, 14, and 15. Take a minute with your neighbor and see if you can solve these three together. So, should have these finished by now. Let's do 13, 14, and 15. This one did not ask us to graph, so I'm not going to worry about the graphs. All I'm going to do is solve these. All right, we're going to start with number 13. Now this one, just like if it were equal, right, if you guys were to see 6y equals 24, you would know what to do. You'd divide both sides by 6, and you'd get y equals 4. This one's going to work the same way, except for it's got the inequality in between it. We're going to divide both sides by 6, just like we would with an equation. 6 divided by 6 is 1, so it's 1y is less than 24 divided by 6, which is 4. Of course, we're going to make that a phantom 1, so we can see this a little bit more clearly, as y is less than 4. Now, we don't have to graph that, and that's okay, because that's all we need for this one for now. This one is going to work a little differently, even though the method is kind of the same. What we're going to do is divide both sides of this inequality by negative 5. Now the problem with this is that it changes since we divided by a negative, it's the opposite. So by dividing by this negative here, we're going to take the opposite of that inequality, which is going to flip it to a less than or equal to. The rest of the math is the same. Negative 5 divided by negative 5 is 1, that's 1x. And 55 divided by negative 5 is negative 11. Well, we're going to make that a phantom 1. And then we get x is less than or equal to negative 11. So this means that, and we can check on this one. We will check because this is the first time we've seen it. If you ever divide or multiply both sides of the inequality by a negative, flip the inequality. So we can check, right? The original inequality was negative 5x is greater than or equal to 55. So I'm going to try something that is greater than 11 just to see and make sure that we didn't make a mistake there. Something like 0. And then we will see if this is true or not. Negative 5 times 0 is 0, which is greater than or equal to 55? No, that's false. So since that is a value that's greater than negative 11, all other values greater than negative 11 would be false. So let's try something that would make it true, or that we think would make it true. Something like, we'll say something less than negative 11, like negative 20. And then we will see if this is true. So negative 5 times negative 20 is positive 100, which is greater than or equal to 55. That's true. So we've shown that we needed to flip the sign because x is less than or equal to negative 11. And again, that's because we're multiplying this by a negative 5 in the original inequality, which is why it kind of flips that inequality right there. If x were positive, then this would remain some kind of a negative value, because a negative times a positive is negative, and no negative is ever greater than a positive. So we need to remember that rule when we're dealing with inequalities. It's the only difference when solving inequalities that's different from solving equalities, is that if we ever divide or multiply both sides by a negative, then we got to flip the inequality. This one is going to work the same way. So I'm going to divide both sides of this inequality by negative 10. Since I divided by a negative, I'm going to flip the inequality. So it was less than or equal to, now it's greater than or equal to. And negative 10 divided by negative 10 is 1, so 1x. 95 divided by negative 10 would be negative 9.5. If you wanted the fraction, that's fine. But I'm going to stay with the decimal on this one and make that a phantom 1. So this means that any value of x that is greater than or equal to negative 9.5 would give us a true statement in the original inequality. So there's our answer. Alright, so we completed all three of those. There they are. Guess we can box in that last one right there, right? All right, take a minute and try these three with your neighbor, and we'll go over it together. All right, here we go. Let's get started on number 16 first. So again, the nice thing about this is we don't need to graph these, but we will solve them. So I'm going to multiply both sides of this equation by 4. So that 4 divided by 4 is 1. Those kind of cancel out, and we're left with x. And 4 times 80 is 320. Now we didn't multiply both sides by a negative, so it's going to keep that inequality the same. 320 is less than or equal to x. Alright, number 17, this one's going to work the same way. In order to get rid of this divide by negative 14, I need to multiply both sides of the equation by negative 14 so that they will cancel out into a 1 or a phantom 1. And negative 4 times 14 should give us positive 56. But since we did multiply both sides by the negative, it will flip the inequality so that it's less than or equal to. So the answer x is less than or equal to 56 would be the answer for number 17. Alright, this one's going to work pretty much the same way. I'm going to multiply both sides of this inequality by 6. Now, since I'm multiplying them by a positive value, it's not going to change the inequality, even though negative 8 times 6 is negative 48. The answer isn't important, even though it is negative. What is important is that we multiply both sides by positive, so it keeps the inequality the same. 6 divided by 6 is 1. We're going to make that a phantom 1 and just show x is greater than or equal to negative 48. That would be our final answer. So there's those three so you can see them. Alright, now we're back to the graphing again. So take a minute with your neighbor, solve 19 and 20, and graph them as well. Alright, let's go ahead and get started. We'll start with number 19. So these ones will work pretty much the same way. To solve this equation, I'm going to multiply both sides of the equation by a negative 8. But since I multiplied them by this negative here, it is going to flip the inequality so that it's less than or equal to. Of course, the negative 8's cancel into a phantom 1, so I'm left with x. And negative 18 times negative 8, you can put that into the calculator. It would give you 144. So this would be the solution, or the inequality that represents the solution. But we still need to put it in the graph. So right in the middle, I would have 144. To the right, 145. And to the left, 143. And at 144, I would have a closed circle because it's also equal to 144. This one is not eating the x, which means that the line should go to the left. Alright, number 20. To solve this one, we're going to have to divide both sides by negative 3. And yes, since we did divide both sides by a negative, that will flip the inequality. And negative 3 divided by negative 3 is a positive 1. We're going to make that a phantom 1 though with the t. Negative 43 divided by 3 would be 43 thirds. And I'm just going to keep it like that. Here's what I'm going to do for the graph though. Right in the middle we'll put that value because that's where it's equal. Even though it's not equal, so it'll just be an open circle. But to the right there, that would be 44 thirds. And to the left would be 42 thirds. Now that could be simplified, but this kind of shows the order of things on that number line right there. So at 43 thirds, that's going to be an open circle because it's just greater than. And it is eating the t, so this line would go to the right. So we have the graph, we have the inequality. That would be our answer. And here are both 19 and 20 together. Alright, here's number 21. Take a minute and try to see if you can solve this one and graph it. Alright, let's go through number 21 here. To solve it, we're going to have to multiply both sides of this inequality by 7 to cancel that out as a phantom 1. So we have b, and we're comparing that with negative 4 times 7, which is negative 28. Of course, we multiplied both sides of this inequality by a positive. So the inequality is b is less than or equal to negative 28. So down to the number line then, to graph. Right in the middle we'll put negative 28, to the left would be negative 29, and to the right would be negative 27. This one is also equal to the negative 28, so we can put a closed circle there. This one is not eating the b though, so the line would go to the left. So we have our inequality and graph there. Number 22, at a baseball game, you can purchase a hot dog for $2, but you only have $10 to spend. Write and solve an inequality to find the number of hot dogs you can buy. Take a minute to see if you can write and solve the inequality to solve this. Alright, let's go ahead and go through this one. So here's what we know, is we're going to say that x equals the number of hot dogs. And we know it's $2 for every hot dog, so if we multiply that by x, that would tell us the cost for the hot dogs. Now, on the other hand, all you have is $10 to spend. And what we know about inequalities is that, especially when it comes to money, you cannot spend more than you have. So how much you have needs to be greater than, or it could be equal to. You could spend all $10 if you wanted to. You could spend all $10, and that needs to be greater than or equal to the cost of the hot dogs. So this is the inequality right here, and we can go ahead and solve that by dividing both sides by 2, which leaves us with x, that's the number of hot dogs. It needs to be less than or equal to 5. So we'll write this out as a sentence. So you can purchase 5 hot dogs or less, or you could say a maximum of 5 hot dogs. It means exactly the same thing. And that completes this problem for us. Alright, now that we've done those one-step inequalities, let's try solving some two-step inequalities. Like numbers 23 and 24, again, you're just going to solve them exactly the same way that you would an equation, except if you ever multiply or divide both sides by a negative, you're going to flip the inequality. Keep that in mind. 1 minute on this one, go. Alright, let's go ahead and go through these. We'll start with number 23. So to solve this one, we want to isolate the ends, which means we don't want that plus 2. We're going to have to subtract it from both sides of the inequality. So that's going to zero out. And then we've got the n over 3. This is greater than 0 minus 2 is negative 2. Then to finish this off, we're going to multiply both sides by 3. So we can see that this is 2 steps. First we subtracted 2 from both sides of the inequality. Then we multiplied both sides of the inequality by 3. That makes that a phantom 1 right there, and n now is greater than negative 2 times 3, which is negative 6. And that would be the solution. (24) will work very much the same way. We don't want that minus 1 with the p's, so let's add 1 to both sides of the inequality. Now addition doesn't change the inequality, so that's not going to change anything there. It will zero out that with that negative 1, so we have p over 9 is less than or equal to negative 2 plus 1, which is negative 1. So there's our first step. The second step is to multiply both sides by 9, which cancels those out into a phantom 1. So p is less than or equal to negative 1 times 9, which would be negative 9. And that one right there is solved as well. And here are both 23 and 24, so you can check your work. Alright, take a minute on 25 and 26. Do these with your neighbors. See if you can solve them. Be careful when multiplying or dividing both sides by a negative. Alright, hopefully you got those done. Let's go ahead and start with number 25. And again, these are going to work pretty much the same way as the last one did. I need to get rid of that minus 2 by adding 2 to both sides of this inequality. So that will zero those out. I'm left with negative 2r is less than or equal to 4 plus 2 is 6. And finally, we'll divide both sides by negative 2. But be careful, we are dividing now both sides by negative. So it will flip the inequality. And negative 2 divided by negative 2 is 1. We'll make that a phantom 1. So we just have r. And 6 divided by negative 2 is negative 3. And this would be our answer. All right, here is number 26. We'll go ahead and solve this one. We got to get rid of that plus 2. So we're going to zero it out by subtracting 2 from both sides of the inequality. That zeroes out. We still got the 8x, which we're going to drop. This is less than or equal to 136. Then we'll divide both sides by 8. Now we're dividing by a positive, so that's going to keep the inequality as less than or equal to. And 136 divided by 8, go and plug that into the calculator. It will give you 17. So x is less than or equal to 17 is the answer for number 26. So there's 25 and 26. All right, numbers 27 and 28, we do want to graph these. So take a minute with your neighbor to solve 27 and 28 and graph them. All right, let's go ahead and get started with number 27. Simple two-step equation. First thing I'm going to do is subtract 5 from both sides of this inequality. So that zeroes out the 5s. I'll drop this negative 7v, which is greater than or equal to negative 79 minus 5 would be negative 84. From here we're going to divide both sides by negative 7. And yes, since we are dividing both sides by a negative here, it will flip the inequality to less than or equal to. So we've got our v because the negative 7's canceled out into a phantom 1. Negative 84 divided by negative 7 would be positive 12. So it appears that this number line does not have the number that we need, so I'm just going to adjust it. Right in the middle I will put 12, to the left would be 11, and to the right would be 13. That's all I really need to show. And at 12, that would be a closed circle, because it's also equal to, and it is not eating the v, so that this line would go to the left. All right, for number 28, we have n plus 3 all over 2. I want to get rid of that over 2 by multiplying both sides by 2. So that's going to cancel those out. Again, it's a phantom 1. So now I have n plus 3, which is greater than negative 2 times 2, which is negative 4. And then to finish this one off, we'll subtract 3 from both sides of the inequality. Now remember, subtraction does not affect the inequality, so it remains greater than. So now I have n, that's zeroes out, n is greater than negative 4 minus 3, which is negative 7. So negative 7 would be right here on the number line. That one is an open circle because it's not equal to 7, and it is eating the n, so this one goes to the right. And that would be our answer right there for the inequality and the graph. And again, there are the two together, 27 and 28. All right, take a minute and solve 29 and 30 with your neighbor. We'll give you guys 1 minute on this one. Go. All right, let's go ahead and solve both of these. We'll start with number 29. First thing I'm going to do on number 29 is get rid of that over 2 by multiplying both sides by 2. So they're going to turn into a phantom 1. 2 times 4 is 8. So 8 is greater than whatever was left of that fraction, 8 plus 1. Now we'll get rid of that plus 1 by subtracting 1 from both sides. 8 minus 1 is 7. Again, subtraction does not affect inequalities. And then we'll drop the a. So 7 is greater than a. At 7 then, we would have an open circle. Because it's not equal to 7, it is eating the 7. I'm sorry, it's not eating the a, so this one would go to the left. And that would be our answer for number 29. Alright, for this one, we got to get rid of that negative 2 right there. So, I'm going to start by adding 2 to both sides of the inequality. And negative 2 plus 2, that's going to zero out. So we're left with x over 2 is greater than 6 plus 2 is 8. And then to get rid of that, divide by 2. We'll multiply both sides by 2 to make that a phantom 1. So x now is greater than 8 times 2, which is 16. So our answer is x is greater than 16. We'll go ahead and graph that. It's an open circle at 16 because it doesn't include the equal part of the inequality. It is eating the x, so this one would go to the right. So there's the graph. And here is number 29 and 30 together. And that completes the worksheets. Again, here's the objective. I can solve 1- and 2-step inequalities. Alright, thanks for watching, you guys. I hope that helped you solve 1- and 2-step inequalities. If it did, please like the video and subscribe to the channel and make a comment below. We'll see you guys in the next one.